All right, we're looking at a problem, an interest problem for my 118 class. We're looking at the finance problem, and in this case, here's the situation. We're going to deposit $2,000 in an account that pays 7% interest, and this is compounded semi-annually. After 4 years, the interest rate changes. It is increased to 7.4%, in this case compounded quarterly. What will the value of the account be after 4 years? All right, the first question to ask is, what type of problem is this? Okay, we've got a lot of different financial type questions we've been dealing with. In this case, we see that we are not dealing with simple interest. We see the words compounded. We are not dealing with simple interest. The next question is to determine whether we're dealing with an annuity or with a compound interest question. The difference between an annuity and a compound interest type question is how often do we deposit the money. In this case, we deposit the money just once, which makes it a compound interest question. There is a single deposit, time elapses, we withdraw the money, how much is in the account. This is different than an annuity where over various periods throughout the life of the loan, money is deposited into the account. That is, we make more than one deposit. So we've decided this is a compound interest question. So the next thing to do is to determine, oh my, this is, here we go. I'm still getting used to using this. Interest. It's a compound interest question, and the next thing to determine is, well, what are we being asked to solve for? Looking at the question, we're asked, what will the value be in the account after 8 years? That is, we're being asked to find the future value of the account. Okay, and there's kind of a delay in my pen. I don't understand. So we're going to be using the future value formula, the compound interest formula, solve for future value, which is A, the future value is equal to the principal times 1 plus the interest rate divided by the number of compounding periods, all to the nt. Okay. Now, what we're going to do is we're going to examine this problem as if there are two separate loans or two steps to it. So first we're going to calculate the future value after 1 year. So the principal after 1 year is our $2,000, and then we've got 1 plus our rate, which during the first 4 years is 0.07, all divided by the number of compounding periods. Well, looking up here, we're told that in the beginning the loan is compounded semi-annually. Okay. All to the 2, and this continues for the first 4 years. Okay. Crunching this number, let's see, I've already crunched it. Crunching this number, we get $633.62. So that number's a little hard to read. This should be a 6. So $2,633.62. That's how much that is the value of the investment after 4 years. Now, this is a continuous investment that we don't withdraw, but we can think of it as if we were to withdraw this money and then simply reinvest it as a new principal. So we're going to consider the next 4 years of the investment, but we're now going to consider it being just a 4-year time period, and we're going to consider the principal now to be the amount of money that is in the account after the first 4 years. This is, again, just simply filling in the compound interest formula for the various variables. The interest rate has changed now. It's no longer 7%. It's 7.14%. And the compounding periods has changed. We are now compounding quarterly, that is 4 times per year. And I've crunched this number as well. This comes out to a final value of $3,495 and looks like 37 cents. So what we see is that we made the investment initially at one interest rate. After 4 years, this was the worth of the loan. What makes this question unique, I think, is that we then use that future value and we consider it the principal for the next 4 years of the loan.